Good evening, everyone. Welcome to this workshop on image processing using Matlab. Today is day 2. I warmly welcome you to the session. Thanks for coming. Thank you for your time. First, I will welcome the early comers. Welcome Nani. Good evening. Sarath Kumar. Good evening. Haripriya. Kushma. Manoj Kumar. Kalyani Shri. Harsimran Hibad. And Milan, Priya Kumari, Mayuri, Prakash, good evening, Soikon, and Chantana, Deepika, Shushmita, Lakshmi, Yuvashri, good evening, Pondinesh, Shai Kumar, Raghav, good evening, Suraj, good evening, Roshni, Saurabh, good evening, Pratik, good evening, Priyanush, good evening, Sachin, good evening, Karthik, Harshit, welcome Bhuvan, welcome Prakash, welcome Vikram, welcome Suraj, welcome Akash, welcome Kapil Dev, welcome Akansha Singh, welcome Naidu, welcome Ruchita, welcome Srihari, welcome Vignesh, welcome Manish, welcome Rajat Gupta, welcome Suraj, welcome. So, good evening to all. I once again welcome you to the session. Thanks for your time and thanks for coming today. So today's session is about basic image processing using Matlab. Okay. So what we are going to learn today. So we are going to cover up how to read and store image. Okay. How to read and store image and how to view the pixels. Like we are going to see definitions about the image, how an image is stored. So that will be covered up in the first topic. And second, we will be covering up the types of images. What are the types of images? Like color scale, color images, how a color image is represented, and what is RGB image and what is HSV image, like, and how to convert the color image to grayscale, and again grayscale to binary. That will be covering up types of images. Okay. And third, we will be covering up mathematical operations, like how to do image addition, image subtraction, and image multiplication, and complement, and how to complement the image. Okay. That will be covering up in mathematical operations in image, because these things are necessary for image processing. And channel separation, like how to split red, green, and blue channels, because when you process color images, okay, some of the algorithms will fit only for the grayscale image. So in order to process for color image, you have to split the planes. So that will be covering up in channel separation. And edge detection, how to do edge detection for an image, okay, and how to apply noise and how to apply filter for the image. And we are going to cover up salt and pepper noise, median filter. Okay. Then we will be covering up what is thresholding, like how to do manual thresholding and how to segment the image by thresholding. That will be covering up this topic, thresholding and image segmentation. And boundary labeling and counting, how to count the number of coins in image. We are taking an image like a coins image and how to segment the coins and how to count the number of coins in the image. This could be used for how to count an apple in a tree, how to count a orange in a tree. Okay. So it's a basic application. And how to do contrast enhancement by using histogram equalization and adaptive histogram equalization. So these are the things which we are going to learn today. Okay. So if you're ready to learn, just type RTL in the chat box. Yes, I'm ready to learn. Okay. Type RTL in the chat box. So before we go into the topic, I'll give you a short introduction about Pantech. Pantech was started in the year 2004 by a team of 4 young entrepreneurs. Like, basically, we are into we manufacture motherboards, like embedded motherboards, microcontroller boards, DSP boards, and FPGA boards. These are the things which we manufacture. And we also manufacture EEG headset and AI development boards, and electrical and electronics, both lab equipments. Okay. So if you want to know more about products and services, you just log on to our website, Pantech.ai. So about me, my name is MK Jeevarajan. Like, I completed my master's in College of Engineering, India in the year 2004, and my bachelor degree in 2002 from Government College of Engineering, Bangalore. So my primary expertise is on board development, like I work on microcontrollers, DSPs, and FPGAs. And I also worked on various algorithms, image processing algorithms. Totally, I have around 16 years of experience. I worked on a lot of around 300 to 400 algorithms on image processing, video processing, deep learning. So this session is about sharing my knowledge with you. So if you want to connect me on LinkedIn, I will provide the LinkedIn link in the chat box. So you could send me a connection request. I'm happy to connect. I'm happy to help. Okay. So I will send you the link in the chat box. Okay. So I have sent my link in the chat box. If you want to connect me on LinkedIn, you could send me a request. Okay. So I would like to give you a small disclaimer, like Pantech is not associated with Matlab. Okay. All the trademarks which was used in this presentation are owned by the respective owners. So if you want to download the Matlab, you could download the Matlab trial version from the Matlab's website. The student version is also very less. The price is very less for the student license of the student version is also very less. If you want, so we have provided the trial version link in the description box. If you want, click the link and you can download Matlab. Okay. And about installation of Matlab, there are a lot of videos available on the internet for the installation. You could search for the YouTube video for installation, and there is also documentation available on Matlab how to install Matlab. It's not a tedious process. All you need to have is have an email. Okay. So, how to read and store image. Okay. So the first topic is how to read and store image and why image processing is important. Okay. So image processing plays a major role on artificial vision, like for robotics vision, the computer vision. So if you take computer vision and the robotics vision, so image processing plays a key role on that part. You just take an audit of number of cameras in the home. Okay. Before 10 years back, we have only one camera in our home. But today, each one is holding a camera on your hand. Each mobile phone has one or two cameras. Okay. One or two cameras. And we have a lot of cameras on the roadside for surveillance. In future, these cameras will also become as an intelligent camera, which could monitor recognize face, and it could send an alert, or it could track the license plate. Okay, so the application of image processing is like image processing computer vision is like it's a growing field, and we have around 3 billion cameras on this world. Okay, so the world today we have around 3 billion cameras. So if you make a small app for a camera, which is very useful, if you could sell it for around 10 rupees or even $1, so it's a billion market. So the market size is billion. Okay, it's a billion market size. So that's why image processing is important. Okay. So today, like the first session, will be covering up how to read and store image. I will explain you the code on the presentation, and then we can go to Matlab and we could practice the code. Okay. I will try to be slow. So how to read and store image. Okay. The first line of the code is imread. Imread is a command which is used to read an image. Okay. Cameraman.tiff is the file name. Okay. By default, this file name will be presented in the root folder. If you want to have your own image, then the image should be placed in the current working folder. Okay. TIFF is the tagged image file format. Okay. TIFF is the tagged image file formats. There are a lot of file formats on images. Like you have JPEG file format, and you have BMP file format. Okay, JPG stands for compressed file format. BMP is bitmap file format. You have PNG, portable network graphics, and PGM, portable gray map, and a GIF file format is there. Okay. There are a lot of file formats. Matlab, if you use a command InRead, it will read TIFF, it will read JPG. So whatever the file format you want, read by this command, except the DICOM images. Okay. You have a separate syntax for DICOM images. DICOM stands for medical imaging. Okay. So the representation of medical images is quite different from the normal images. So the first line of the code is A equal to imread of cameraman reads an image. Ensure is used to display the image in an axis. In pixel info, like IM pixel info is used to view the image, view the pixels of image. If you want to view the pixels, because an image is represented in terms of a matrix form. You take a grayscale image, you will get a single matrix. Depending upon the size of the image, the size of the matrix will vary. If you take a small image, the size of the matrix will be less, and that is known as resolution. If you take a bigger image, the size of the matrix will be more. This is for grayscale image. For color image, you will be getting three matrices. You will be getting a matrix for red, matrix for green, and matrix for blue. RGB format. Only the a combination of the colors will give you the pixel. Like it's a 24-bit representation. So InWrite is a command which is used to store the image. So Matlab will support various file formats. You could use the help command to navigate for InWrite and InWrite and to know what are the file formats will be supported by Matlab. Okay. So InWrite of test.png will read the TIFF format and it's stored as a PNG format. Okay. And for DICOM images, you need to use a command like DICOM info is the command which is used to read the DICOM images. And DICOM read will give you the information about the file. DICOM info will give you the information about the file. And DICOM read is a function which is used to read the image. Okay. So I'll go to Matlab and I'll show you the demo. I just opened Matlab here. The first thing is to create a folder. Okay, and copy the path. I'm going to copy the path and I'm going to change the path. Okay. So change the path. Once you change the path, then I'm going to open. I'm just type edit in the command window to open editor window. And CLC for clear and variable clear. Okay. So I'm going to read an image and read of single camera man.tiff. Okay, I'm going to read an image. In show of A is used for display. Okay, in pixel info is used to. Okay, in pixel info is used to like to view the pixels. I'm going to save the program. Save as example one. Save as example one, and I'm going to run the program. So if you check this image, like the image has been stored in a variable A. Just type whos of A, you will get the size of the image, like 256 rows and 256 columns. If you want to view the pixels, like you could view the pixels like you keep the cursor, so it will show the pixel at the bottom. So XY locations, the first info is the XY locations and the pixels. The pixels will have a value for a grayscale image, will have a value between 0 to 255. It's an 8-bit representation. Okay. So I repeat the code. First, you read an image by using a command called InRead. It will support various file formats. I have read cameraman.tiff, which was stored in the default folder. Okay. I have an image here, rows.png. So if I read rows.png, PNG stands for portable network graphics. Okay. Run the program. So this is the image. So for this image, if you check the size of the variable, it is 3. Okay, because it's a color image, it has 3 matrices. For red, you will have a matrix, for green and for blue. Okay. So if you want to view the pixels, so you just keep a cursor on the at any locations. You will have 3 values at the bottom: red, green, and blue. Okay. You have 3 values RGB format. Okay. RGB format. If this image was stored in some other folder, then you have to include the path name and you have on the file name. Okay. It has to be included here. Okay. So the next is DICOM read. You just type help DICOM read on the command window. So you get a sample code here. I'm going to copy the code here. This is to view the medical images. Okay, this is to view the medical images. So I keep a breakpoint to show the information, okay, to show the information about the image. So click run. So if you check the information, if you check the info, okay, if you check the info, it contains like all informations like what is the file name and what is the file modified date. The file modified date is on 2000. Okay, file size, format, what is the width and the height of the image, what is the bit depth, and what is the color type, grayscale. Okay, so all this information will be there, and then like, so you could use DICOM read. So this is the image. So this is the image. So since it's 16-bit format, you have to use this text. So I'm running this. So this is the image. So here I don't have this square brackets because it's an 8-bit. Okay. Since here it is double, the image is 16-bit. The pixel is 16 bits. Okay, you check it. You check this information on the info file. Like info, like the bits allocated is 16. Okay. Okay. So if you want to store on the other name, you could use I am right of A, whatever the file you want. Test, I'm putting test as JPG format. Okay. And I'm going to run the program. So if you check here, like the test.jpg is created on the current folder. Okay. So we have read rows.png, we have read rows.png, and we have write this test.jpg. So I am right is used to store the image. Okay. So if this code is clear, if it is clear for you, just type clear in the chat box. If the code is clear, you just type clear in the chat box. I will repeat the code one more time. A equal to imread is used to read an image. Okay. Inshow is used for display. And show is used for display. And I am pixel info is used to view the pixels. Okay. It is used to view the pixels. I am right is used to store the image. This is for normal image. And from line number 7, like it is for DICOM images. If you want to read a DICOM images, DICOM info, okay, will give you the information about the DICOM file. And DICOM read is used to read the image figure. So this is a program. Okay, so we will move to the next program. Okay, I will move to the next program. So the next is types of images. Okay. The next is types of images. So in this, we are going to convert, like we are going to take an RGB image, color image, and we are going to convert that to grayscale, and then we are going to convert the grayscale image to a binary image. Okay. So in first, I'm going to read the image. A equal to imread will read an image. Okay. Subplot is used to display multiple images on a single axis. Okay. If you want to have multiple images on a single figure window, then you have to use subplot. Okay. The first value stands for rows, and second value stands for the column. The third value stands for the index. Okay. So we are going to have 1 rows and 3 columns. Okay. First is the first index, and inshow of A is the image for display the image. Okay. RGB to gray will convert that to a grayscale. So first read an image, convert that to a gray by using RGB to gray, and then subplot of 1, 3, 2 is for to display the second image. Okay, and show of B. And for binary, you have to use IN to BW. Okay, IN to BW is for to convert the grayscale to binary. So we are going to read a color image, convert that to a grayscale image, and convert that to a binary. Okay. So I'll go for Matlab. And I create a new program. Type CLC here. I'm going to read an image A equal to imread of close.png. I have read the image. Okay. Now I'm going to convert this to grayscale first, RGB to gray of A. Okay. To convert that to a binary, image to binary. Okay. Okay. So if you want to view the first image, subplot of 1, 3, 1. Okay. In show of A, this is for display the first image. Okay. And I'm going to copy this. So 1, 3, 1. This is 3, 2, and this is 3, 3. This is I am show of B and I am show of C. The code is very simple. X2. There is no complexity in the code. You read an image. A equal to imread of post.png. Convert that to a grayscale. Okay, grayscale, black and white image, or RGB to gray. You cannot convert from color to from gray to color. There is no command to convert a color to a grayscale image to a color image. So RGB to gray is there. Okay. So if you run the program, so I'm going to close all the previous programs. Okay. Figure is to open the new figure. So if you check here, so this is the color image, grayscale image, binary image. Okay. For color, you will get 24-bit pixel. For red, 8-bit. For green, 8-bit. For blue, 8-bit. And for grayscale, you will be getting only 1 pixel, like 8-bit. And for binary, the value of the pixel will be zeros and ones. Okay. If you want to visualize those values, just type I am pixel info. I am pixel info. You could also resize this image. Like if you want to resize this image, B equal to, okay, I'm going to A equal to, I'm going to resize the image 256 of 256, the image of size 256 of 256. Okay. To change the size of a matrix, to change the size of the image. Okay. So if I want to view that, so I'm going to put 2 rows and 2 columns. Okay. So I'm going to put 2 rows and 2 columns here. 2, 3. Okay. So this is the first image. So I run the code here. So this is the original image. Okay. Here we have changed the image. So you could check who's of, if you put who's in the command window, it will tell you the size. Like the first input image is of 595 rows and 730 columns. So into 3 stands for color image. Okay. We resize the image to 256 into 256 into 3, 256 rows and 256 columns. And this is grayscale. So 250, you are getting only a matrix, single matrix, 256 into 256. And this is the binary. You could also click the workspace and you could view the pixels. So this is the binary image which has only zeros and ones here. Okay. For grayscale, you have the value between 0 to 255, whereas for color image, okay, color image you will have 3. For red, you will have for red and green and blue. Okay. Red, green, and blue, 24-bit. It was not viewed in the workspace. I'll show it on the next experiment. So you could keep the cursor here, and you could view the pixels on the bottom RGB. So totally you'll be get 24 bits. I will repeat the code. So first read this image. A equal to imread is used to read the image. This resize is a command to change the size of the image. If you want to change the size of the image, you could use IM resize of A of 256. Whatever the value you want, whatever the size you want, you could replace, you could mention that. It will resize the size. Okay. RGB to gray is used to convert that to a grayscale image, black and white image, and grayscale image. And IM to BW is used for to convert that to a binary. Okay. And this is for display. Is that clear? Is that clear? So subplot, I will repeat how this. So in this, I will repeat subplot 2 rows and 2 columns. 2 rows, it means 2 rows and 2 columns. I am show is the first image. So this we denoted 1 here. So the second image is A1 resized image, and third is this grayscale image, and fourth is this binary image. If you're clear with this program, just type clear in the chat box. Okay. Thank you, Sai Priya. Thank you, Pradeep. Thank you, Montu Patel. Thank you, Hrithwik. Thank you. Thank you, Salim. Thank you, Sarik. Thank you, Renu. Thank you, Aditya. Thank you, Nayan. Thank you, Anikat. Thank you, Saurabh. Thank you, Anubhav. Thank you, Karthik. Thank you, Alia. Thank you, Sunil. Okay, okay, we can go to the next. We'll go to the next. The next one is mathematical operations in image. How to do image addition, how to do subtraction, and how to do complement, and how to do multiplication. So that we will cover. So this we will straightly go to Matlab. So I'm going to create a new program. I'm going to create a new program. CLC for clear string, clear for variable clear. So every syntax will have an example code. Make use of the code, because sometimes Matlab will have capitalization. Okay. So help in add. When you type help in add, you get a sample code here. I'm going to copy the sample code. Okay. I'm going to copy the sample code here. So save and run the program. Example 3. Save and run the program. So this is the input image, and this is the value which we have added. We have added 50 for each and every pixel. Okay, IM will add pixel. For example, if I add 250, so I'll make this as a single plot, subplot of 1 comma. We are going to have 1 rows and 2 columns. Okay, and this is the first image. Okay. This is the second image. We are going to have 1 rows and 2 columns. And this is the first image. So I'm going to give figure, open a new figure. So I'm going to use close all to close any figures which was open in the previous program. Okay. So click run button. Okay. So I have added 250. So the maximum value a pixel can have will be 255. So what if I add 10? Okay. 10. No, not a big variation. So I'm going to add 50. Okay. So the intensity changes. Okay. 50. So the same, we could also do the same thing by IM subtract. So IM subtract will minus 50. Okay. Minus 50. You could also check in this space. So you click I, the first pixel value is 122, whereas the modified value is 72. Okay. There's a 50 difference on it. Okay. 122 minus 50. So this is IM subtract. So IM addition, IM subtract will be used for some mathematical modeling. So IM subtract. So IM complement. So just type help IM complement. So this will display program. Okay. You just copy this program. Right click, go for evaluate selection. Okay. Evaluate selection. So this is an input image. This is the input image, class.png, and this image was stored in the Matlab root folder. And this is the complement image. Okay, zeros becomes ones and ones becomes zeros. So IM complement is mostly used on binary image processing. Like, when you do some morphological operations, then IM complement is used. Okay, so this is for IM complement. So far we have covered up addition and subtraction. I will repeat the code one more time. You read an image. Okay, you read an image. I am subtract or I am add will add a pixel value. You could also read two images, and you could also add. So I'm going to add. I'm going to read one more image. Read. I am read. Okay, of camera man.diff. I'm going to read this image. So I'm going to add this one. I am subtract instead of I am subtract. I'm going to have I am add. So if you want to, I'm going to change the subplot for to view all the images. Okay. Save the program and run the program. Okay. Cameraman.diff showing some error. It should be 3. Okay. So save the program and run the program. So we have added this image, we have taken this image, take two images and we have added these images. So this is for image addition, image subtraction, and IM complement. So multiply help IM multiply, get a sample code. Copy this code, right click, go for evaluate selection. This is the input image. And this is the multiplied image, 0.5. 0.5 is multiplied. Okay. So this is image multiplication. I am multiplied. Okay. So far we have covered up image addition, image subtraction, and I am complement, and I am multiply. Okay. If it is clear, I just type clear in the chat box. We'll move to the next session. Clear. Not working. Sir, link is not working. Is it clear? You just type clear the chat box. Okay. We can move to the next experiment. Okay, so we will go for the next experiment, like color channel separation. Okay. So how to split red channel, green channel, and blue channel. Okay. Just read an image. And, how to split this into channels. First, I will explain you the code on the. First, I will explain you the code. First, I will explain you the code on the presentation. Then we can go for Matlab and take the code. Okay. So A equal to inRead of rows.png. Okay, it's used to read the input image. IM split is a command which is used to separate red channel, green channel, and blue channel, and this command is available only on the latest version of the Matlab. I think it should be on 2019, about 2019. Okay. If you have used 2015 or 14, this command is not there. IM split command is not there. I'll tell you like how to do that for 2014 or 2013 version. Okay, so figure of ImShow of what is to display the input image. Okay. So this R of colon comma 1 you have to load the red component. Colon stands for it take all rows and all columns. Okay. You take all rows and all columns. You load the red channel. The rest green and blue channel you make it as 0. Okay. To visualize the red channel, you make green and the blue channels 0. And you just display the image, you will get the red channel. Okay. Similarly, for green channel, you have to load the green and you have to load the first and third channel. For green is 2, red is first, red, green, and blue. So R equal to 1, and green is 2, and blue is 3. Okay. So load the green channel, then you make as 1 and 3 is 0. Okay. And for blue, you load the blue for the third value and make 1 and 2 is 0. We'll go to the program Matlab and I'll show you the output there. Create a program. CLC for clear screen, clear for variable clear. First, I'm going to read an image. Okay. I'm going to read an image of rows dot png. I'm going to read image. Read image. Okay. Then I'm going to split this comments RGB. Okay. RGB equal to IN split. It's a command to split the channels. Okay. To split the channel red component. If you want to view the red component, so red of colon comma 1 equal to R. Okay. So I'm going to copy the same thing. The colon comma colon stands means it takes all rows and all columns in the image. This is the first two columns stands for the position, like the matrix size, and this is the plane. Okay, this is the plane. First is for red and two, and this is for green and blue. I am making green and blue as 0. I'm making green and blue as 0. Just I'm going to figure, and I'm going to show the image. Figure I'm show red. Save the program. Example 4. Okay. Save the program as example 4 and run the program. So this is the red component. Okay. So I repeat the program for the red component. First read an image. A equal to in read will read the image. Okay. IM split is a command to split the red component, green component, and blue component. Because when you do color image processing, you have to split the channels and you have to process the algorithm. Okay. Some algorithms will not work for the it will work only for the 2D. It means a matrix. So you have to separate those matrices. Red matrix separate, green matrix and blue matrix, then apply the algorithm. So if you want to visualize the red component, load the first one and make green and blue as 0. If you want to visualize the green component, okay. So I'm going to copy this one. Copy. And I'm going to change this screen. Okay. I'm going to load the two. I'm going to load the green value. I'm going to display the green value. Okay. So evaluate selection. So this is the green component. Okay. So I'll repeat the code, like split the component, okay. Load the red component here, and you make the rest other two as 0. And for green, load the green component. Green should be 2, red is 1, green is 2, and blue is 3. Okay. So if you want to view 3, like for blue, if you want to view the blue, that's 3 actually. So blue should be 3. Okay. Load the blue component. Make the rest of the component as 0. 1 and 2 as 0. Okay. And run the so red and the green and this is. So this is the separation of red and green and blue planes, RGB planes. Okay. So if you're clear with this, you just type clear in the chat box. Okay. If you're clear with this program, just type clear in the chat box. Thank you, Ranjita. Thank you, Ranjita. Thank you, Komal, Ashilash. Okay. If you're clear with this program, just type clear in the chat box. Thank you, Sriani. Thank you, Girija. Okay, so we'll go for the next session on next experiment on edge detection. So I will explain you the code on the presentation first, and then we'll go. First read the image. Edge detection will work only for the grayscale image. First read the image and convert that to a grayscale. RGB to gray is used to convert that to a grayscale, and edge is a command. Edge is a command which detects the edge from the image. There are a lot of algorithms like Canny edge detection is there, Sobel edge detection is there, and Prevital edge detection is there. So Matlab will support like 3 to 4 to 5 algorithms are there on edge detection. So you could use the help command to visualize what are the methods which will support by Matlab. Okay. So and display the edge. Okay. So edge detection is used to visually to get features on the image. Okay. So I'm going for Matlab now. So I'm opening a new program. Okay. Equal to in read is to read the image. I'm going to rows.png. Okay, rows.png. First I have to convert this to grayscale, RGB to gray, A, and then H. Okay, to check, you could use help H command to implement the syntax, okay? Because sometimes it involves capitalization. So always use help command to write the programs. So B, this should be B. Okay. This is can. Okay. So if you want to figure of show of C, okay. This is example 5. Save the program, run the program. This is example 5. Okay. So this is the edge detection. Okay. So if you want to view the input image, figure of show of V. So this is the input image, okay, and this is the edge detected image. Okay. Edge detected image. The other methods you could use help edge, and you could get the method like if you want to read, you just load the method here, okay, and you run the program. So this is by preview, okay, and can. Okay. So I repeat the code again. So first read an image. If it is a color image, convert that to a grayscale image. If it is not a color image, then you could straightly go for this command edge of B, the method, okay, and the C, figure of image of C will display the okay, edge detection. So noise and filtering. So noise and filtering. So like first read an image. There are different type of noises like salt and pepper noise, Gaussian noise, Poisson noise, multiplicative noise. There are different type of noises. Matlab supports a lot of. You could use help command again. You could use help command to know like what are the noises will be supported by Matlab. Okay. And there on each noise you have to apply different kind of filter. Like salt and pepper noise, you have to apply median filter, and Gaussian noise, binary filter will be better for that. Okay. So and you could also use CNN based denoising application. So in this program, we are going to add a noise to the image, salt and pepper noise to an image, and we're going to use a median filter. So I'll go to the Matlab. So the first command is imread is to read the image. Im noise is a command which is used to add the noise. And salt and pepper, this is the noise variance. 0.12 is the noise variance. Based on this value, the number of the noise will differ. Okay. And MED filter is the median filter. Median filter. This 5,5 is the mask, like the nearest neighboring pixel. If you put 3,3, it will take the nearest three neighbors, totally 9 values. Okay. The nearest neighbors will be 9 values. If you put a 3 cross 3 mask, okay. If you put a 3 cross 3 mask, it will take the neighbor value, take the median value of the neighbor value, and replace the pixel value. So that's how median filter works. And there are a lot of documentation is available on the internet for median filter. Okay. So I'm going for Matlab now. So CLC, okay, clear and close out. Okay. So I'm going to read equal to read of cameraman.diff. First I'll show for cameraman.diff. I'll show for a grayscale image, and then we can go for color image. B equal to IM noise. So you put help IM noise here, so you will get a sample syntax. Okay, sample syntax. Copy the syntax. And you could make use of the syntax to know like the single quotes and everything. So it's sort purpose. So noise variance. MED filter 2. Okay, MED filter 2 of B comma. First I'm going to apply 3 cross 3 mask, and I'm going to show you. Then subplot. Subplot of 1, 2, 1. Sorry, 1, 3, 1. Okay, we are going to have 1 rows, 3 columns, because totally we have 3 images. Okay. First, I'm going to display the first image. First, I'm going to display the first image. Okay. And then second image, third image. Okay. And show of 2 and 3. Show 3 and 6. Okay. So save the program. Example 6. Okay. I will explain the code one more time. Okay. So this is the input image. Okay. And this is the noisy added image. The noise added image started up. Okay. And this is the filtered image, median filtered image. So image, if you change the variance here, 22, okay, 22. So you will get a difference. Still, you have a noise here. So in that case, if you go for a 5+5 mask, okay, go for a 5+5 mask, you get some improvements. You get some improvements on the, because it takes the, like 3+3 is the immediate neighbor, and the next round is 5+5. Okay. So this is the input image. This is the noisy added image, certain noise added image, and this is the output image. Okay, I'll repeat the code. To read an image, immediate cameraman.diff. Noise is a command. Okay. MED filter 2 is for median filter. To apply median filter. For example, you have color image here, rows.png. Run the program. Okay. So if you check here, like we got the noise figure of I'm sure B. Okay. We got the noisy image for color, but a median filter is not working for color image. Okay. In that case, you have to use the IM split command. Okay. You use the IM split command. Okay. Split command for B. Okay. Give this separate into red, green, and blue. Copy the code, and you have to repeat for 3 times. Okay. You have to repeat the code for 3 times. First, you process the red plane. Second, you process the green plane, and then you process the blue plane. Okay. So red, green, and blue. Okay. Finally, you want to merge them. Okay. C of colon, comma 1 equal to red. Okay. And this is green and this is blue. So what I have done is I have split that into planes. Still it's not 2 and 3. Okay. Okay. Salt and pepper noise. I am read figure of I'm sure of A and B. Okay. Or GB. This should be B1. Okay, this should be B1 and this should be B1. Okay, let me check again. Okay, so if you check this, this is the input image, this is the noisy added image, this is the filtered image. Okay, this is a filtered image which is sort of a median filter. So I'll explain the code. You read in color image. Okay. IM noise is used to add the salt and pepper noise. Okay. You use IM split command to split into 3 planes. You separate the red component, separate the green component, and separate the blue component. Okay. Then apply median filter. You apply median filter for the red component, apply median filter for the green component, and apply median filter for the blue component. You separate and you split the planes, and you operate separately. You apply median filter separately. Okay, for red component, for green component, and for blue plane. Then again you combine that to a single image C or GB. Finally, I have displayed this one. I have used B1 because like we have used the variable B here, so I can make this IM noise a separate variable. So I repeat the code. In read is to read the image. I am noise is to add the image. This is to split the brackets. This is for color. Okay. For grayscale, you could apply for one time and process 3 times. Okay. Then apply. This is the output. Okay. You have the image, have the nicely added image, and this is the median filter image. If it is clear, you just type clear in the chat box. Clear in the chat box. Snake was saying thank you. B, thank you. Roy, thank you. Okay, thank you. So we can go for the next program on thresholding and image segmentation. We're running out of time. So I'll complete this with thresholding and image segmentation. Okay, thresholding. So both are same, like counting thresholding and image segmentation. Okay. So I open a program. We'll close the session with this program. Okay. So thresholding, I will combine these two examples into a single program. A equal to in read is used to read the input image. Okay. Points.png. It should be png. Okay. Points.png. Okay. So first read the input image. So I'm going to convert that to a binary figure. First, I will show you the image. Figure I'm showing here. Save the program as example 7. Okay. Run the program. So this is the input image. I'm going to apply binarization. Okay. B equal to A greater than 100. Now I'm going to show you the binarized image. Okay. So this is the input image and this is the binarized image, and it has some noise over here. So it has some noise over here. If you count the coins, now, okay, it's a variable, just variable. Okay. BW label is a command for boundary labeling. If I'm going to count the coins, no, this of num will give you the number of coins. Okay. So the number of coins is 10. Okay. Boundary label, this number of coins is 10. If you want to apply a median filter, filter of B, comma, okay, 3 plus 3. So you will get a clear image. So figure you have to see. So I'm displaying the median filtered image. Okay, this is the median filtered image. Okay. And boundary labeling will give you the number of finds. Okay, boundary labeling. So if you want the segment, then like I'm going to so C figure of show of segmented image. Okay, segmented image. Okay, run the program. So this is a segmented image. Okay. So I will explain the code. We have read image. This value is manual threshold. Okay. There are a lot of algorithms available for automatic thresholding, like we have Wotsu thresholding, Wotsu method for thresholding, and lot of thresholding like techniques of that. Okay. I have seen the image, and I have given 100. Even if you give 150, it will work. You will get the same number of coins. So for 150, the threshold 150 doesn't work. Like the number of coins it shows is 24. Okay, how to give the correct threshold? Manual. Okay. its number of coins is 10. Okay. So manual thresholding, like is is not used actually. You have to go by any algorithms, and then we have applied median filter. Okay, we have applied median filter to remove the noise, and this is to convert that to a double. It will be in double format, so we are converting that to an unsigned integer 8 form. To convert this is for just a data type conversion, and this is for segmentation. Okay. Here we are just multiplying this input image with this mask, so that will give you the segmented image. Okay. This boundary label, BW label, is a command which is used to count the number of coins. It will give you the closed component, connected component. You just type BW label in the command window. It will give you the explanation. So it just it counts the number of closed connected components. Okay. So that you could estimate, like we could get a number of how many coins are there in the image. Okay. So inbreed of coins with JPG. So if it is clear, just type clear in the chat box. If it is clear, just type clear in the chat box. Okay, so let us go for the next one. Okay, with this, I close the session. Okay. Like we have a 30 days internship program on Matlab. So it's a 30-hour session. It's like we have covered up the basics of Matlab, basics of image processing, and we covered up basics of video processing, basics of computer vision, and the basics of neural networks, fuzzy logic, neurofuzzy logic, and machine learning, deep learning, like we have covered up machine learning, deep learning, app development, as well as GUI, graphic user interface development, speech and audio processing, and totally around 15 projects has been included, like starting from compression, segmentation, gesture recognition, augmented reality, and object recognition, steganography, cryptography, semantic segmentation, and so a lot of projects like face detection. So all these projects are included on this. Like if you want to avail the internship, like you could avail on a discount. It's a 30 days internship, and the login will be valid for 3 months. Like currently it is for 2 months. It could be extended for 1 more month. Okay. The valid will be valid for 3 months. So the offer price will be around 750. If you want, you could enroll. Like you could avail the offer. So it's just a 30 days challenge. Okay. So you learn 1 hour a day. Definitely will become a master on image processing and on various techniques like compression, segmentation, denoising, okay, and everything. So we have a portal. Like I'll show you the portal. Okay. So we'll provide a login like this, and you'll be having the PPTs as well as you'll be having the source codes, and you will have the video. You could watch on it one time. So these are the one, like image processing using Matlab, video processing using Matlab, okay, image processing, graphic user interface, application developments. So like 6 minutes video, 3 minutes video, okay, and the YouTube video also. So image segmentation, compression, feature extraction, okay, face recognition, real-time object detection, image denoising, Arduino programming, image quality metrics, augmented reality, Raspberry Pi programming using Matlab, Jetson Nano programming using Matlab, audio processing, speech processing, and cryptography, and SLAM and semantic segmentation. So it's a 30-hour session. So you could avail for some free rupees. Thank you so much. Thank you for your time. I will take the questions. Have a Q&A session. You could just post your question on the chat box. I'm happy to help. I'll go through the chat. Happy to help. Arun Vagish, you could view the video for almost around 90 days. Like actually, currently we enabled for 2 months. You could you could view at any time. Okay, so on request it will be extended for another 1 month. So thank you Anjali Singh, thank you Farouk. I didn't feel today. Like thank you Anjali Singh, thank you Farouk, thank you Gaurav, Triptika, thank you Ranjit Singh, Rohit Kabur. Okay. So if you have any questions, you just would like to take 5 to 10 questions today or even more. If you have a questions, you just type in the chat box. Going to the chat box, I will bring the chat box to the main menu here. So Harshit, best projects. Harshit Gopal asked the best projects on image compression. See, actually, there are a lot of image compression methods. Like starting from DCT, you have DCT based image compression, weighted based image compression. Epcot is there, and embedded zero weighted algorithm is there, and spit algorithm is there. A lot of image compression techniques are there. Like so, you could choose any one of them. Choose any one of them. It depends upon the context whether to go with the medical image processing or normal image processing. Because when you go for medical image processing, it should be lossless. Okay. Whereas for consumer grade applications, you go for a lossy compression scheme. So it depends upon the context, what context you are going to like, choose. Polish, sir, is for internship. Where will I get the offer? Polish, you could log in to learn.pantechsolutions.net. You might have received an email with the login. Okay. Otherwise, use forget password option. Use forget password option, and you could view. Okay. Deepen, okay, attendance link, Shaw, how to contact for doubt purpose, Shaw Vatsal. Shaw Vatsal, like we will provide you the group, like VIP group link, like on, so you could post the questions there. It's a Telegram link. Okay. You could post the questions. If you have already paid, Shaw, if you have already paid, like you just send a request to sales@pantechsolutions.net. So we will provide you the VIP group link where you could post the questions. It may be on Telegram or maybe on WhatsApp. We have both. Akansha Singh, job assistance. Currently, actually, we don't have job assistance as of now. Business for Tech Matlab software is it's paid. Actually, you could use the trial version. Okay. So if you have any doubts, like you could post the questions on the chat box and go through it. Thank you, Ramakrishna Reddy. Thank you, Ramakrishna Reddy. Thank you, Kapil Dev. Thank you, Jasmine. Thank you. Send us WhatsApp. Thank you, Sapana. Like, yes, I will arrange you the WhatsApp link. A masterclass. I think NSK you were asking about. You have completed a masterclass using Python, right? Yes, you could also in Matlab. You could also study Matlab. By Matlab, we could speed up the process on algorithms. Okay. How to load image in program? Like you could use the InRead command. Can you please give the applications? Raj Manohar Reddy. A lot of applications are there. Like I'm not getting your questions. Like for image processing application, it's a lot of applications are there. Like face recognition. Everything is like image processing. It should be combined with other techniques like deep learning and machine learning. So the application is much more. Shubham Singh, can you brief more on image segmentation? We have a separate session on image segmentation, but not on this. Like it's a wide area. There are a lot of like you have semantic segmentation and k-mean segmentation. A lot of algorithms are there in image segmentation. We have caught up that, and we have caught up 2 sessions on the internship on image segmentation, the semantic segmentation as well as the image segmentation. One which is one uses the deep learning, the other uses the normal k-means algorithm. Thank you, Sarika. Thank you so much. Arun Vakish. Wavelets we have covered up on the internship portal, the two-dimensional discrete transformation. Computer vision also, the next 3 days we'll be covering up only on computer vision and graphic user interface and the CLM. No, we have not covered up wavelets in the forthcoming sessions. If you want the basics of wavelets, like you could get it from the Mathos site. How to download Matlab software? Ramakrishna Reddy, like you could go visit Mathos site and you could download the trial version. Singh Satyendra, thanks. Thank you so much. Can we use online Matlab? Nandini Joshi, yes, you could use online Matlab. If you have like this info, I did not understand certificate. Minimum, like you need a 4 days session. Like you just submit the attendance form. Minimum 4 days you have to submit for a certificate. Pravanjan, thank you. And Salman Khan, Matlab its cost, like it is not freely available, it's a proprietary version. Okay. Matlab is similar to Python programming. Both are different. Like Matlab has its own language, own syntax, both are different, but the algorithm is same. Okay. The algorithms on Python and Matlab is almost same. So if you want to speed up the learning time and speed up the process of implementation, you could use Matlab. Most of the companies use Matlab for speed up the process, to speed up the implementation process. Okay. Chandani Mahajan, thank you. Thank you. Chandramurthy, transform. Aish, thank you. Thank you, Aish. Python or Matlab. Maurya, image processing with Python or Matlab, which is better? Okay, see, I want you to learn both MATLAB and Python. Okay, so MATLAB, there is some there are a lot of input libraries in MATLAB which could speed up the programming time. So that's the advantage of MATLAB, because they release MATLAB versions for each and every 6 months. Like for a year, they have two versions. Like if you take last year, like 2020A and 2020B, they have released. This year also 2021A and 2021B will be there. Each 6 months they will upgrade the MATLAB versions with new libraries and new algorithms. So I want you to learn both. If you ask me a question to learn MATLAB, just learn MATLAB and Python. So if you want to become a data scientist, or if you want to become if you're looking a career in artificial intelligence, then both are mandatory. Okay. Ramakrishna Reddy, like currently we are online only. Girija, thank you. Girija Pavi, thank you. Barnwall, thank you. AK Barnwall, thank you. So Raj, can you provide Raj Manohar Reddy? Yes, I'll try to share you on the Facebook group. If you have not joined in Facebook, the closed group, the private group, I have shared the link through email. Just you could join. Okay? You join on the Facebook group. So I'm going to share a lot. I'm going to share a lot of values on them, and we are going to release a lot of content on the Facebook group also, in the closed group. Okay? So if you are not joined yet, you just join the Facebook group. So you'll be getting a lot of deliverables there. Veronica, thank you. Ranjita, thank you. Bhuvanesh Kumar, thank you. Harita, thank you. So, any questions? Any questions you have? I'm going to close. Any branch in Pune and Maharashtra? No, we don't have any branch in Pune as of now. And AK Barnwall, sir, I'm looking for AI. For AI we have AI using MATLAB, and we have also AI using Python. If you want to register for internship, you will get an email. You just subscribe to our email. You get an email during the offer. Okay. Sai Praveen, thank you. Thank you, Sai Praveen. Ramakrishna Reddy, thank you. Suraj Yadav, thank you. Rohit, or having what limitations? See, I have not worked on SCA lab. Sorry, Rohit, I have not worked on SCA lab. So I'm not able to comment on this question. Sorry. Vishal Patel. Thank you, sir. Matlab or Python. Okay. Thank you, Vishal Patel. Thank you, Shivam. Yesterday, attendance link will be Shivam. Attendance link will be closed within 2 hours of time. Okay, so you please be on time to send the attendance. It will be extended for 2 more hours. So it will be there. Raj Manohar Reddy, how worthwhile is it to a C branch? MATLAB is absolutely necessary. See, almost there is almost all companies, most of the companies they use MATLAB. If you check applications, even banking, marketing use MATLAB. There's a company in Chennai called Neurofocus. They use MATLAB for neuromarketing, like for analysis of the EEG signals for advertisements. So most of the companies they use MATLAB. Software engine, how MATLAB is useful in the sense? Okay. I'm not sure about the question, but you could if earth science involved mathematics, if the answer is yes, then definitely there is a role on MATLAB. Okay. If you use mathematics, then it's sense. Can we create own functions? Yes. We have a video on yesterday. The video is available. You could go through the yesterday session. Like you could create your own functions in MATLAB. Surendra, you could create. Prakash, thank you. How much I have to print? I'm not sure. Bits infotech. I'm not sure. The student version is around. I guess it might be around 2,000 rupees per year. 2000, you could approach MATLAB, but it's very less cheap. The students version is very cheap, and the add-on will be around 250 rupees, I think. So the deep learning toolboxes are some $5. They're asking $5 for toolboxes, so you could pay for the toolbox you need. Prakash, you could use MATLAB for mechanical. Yes, use MATLAB for mechanical. Banu Prakash, suggest me the best companies that use MATLAB. Almost most of us, the GE, if you take the Giants, GE and most of the companies they use MATLAB. What I suggest is you have to have MATLAB. You should know MATLAB. I'm not saying you should know only MATLAB. Okay? It's just an add-on. You also want to have knowledge on this if you're going to if you're looking for AI development, because when you come for artificial intelligence, you have image processing, you have deep learning, you have machine learning, you have computer vision. Everything comes together, like speech recognition, natural language processing. Everything coming together. Okay? So you should have knowledge on MATLAB on various topics as well as on the other language also, Python on. Session will start at Jagadish. Session will start at 6 p.m. Thank you, Ambedkarji. Thank you, Nikhil. Sir, no link till now. How many days MATLAB is allowed? Can we use MATLAB for forensic science? Yes, Subham Verma, you could use MATLAB for forensic science. Yes. Yes. How MATLAB is used for mechanical workshop? Compress the ECG signal. Yes, but you should go with Shivaneshwara Rauri. We can compress the ECG signal, but it should be, you have to choose the lossless compression scheme. Since it's a medical application, you have to go with the lossless scheme. MATLAB will be free for 30 days. Okay. Thank you so much. Thank you once again. Meet you tomorrow on the next session tomorrow. Until then, bye bye. Thank you.